Hello friends, welcome to my channel. My name is Amrit Purandare. In this tutorial, we are going to learn the fourth solid principle, that is interface segregation principle. We have already seen the first three principles. If you guys have not checked those tutorials, please go ahead and see. I will post the link into the description. So now let's go ahead and start the discussion with the interface segregation principle. So the as per definition, interface segregation principle says no client should be forced to depend on methods that it does not use. So here client means all the classes or the modules, and we should not overburden them with the responsibility that they are not responsible for. Let's go ahead and understand this properly. So in our code base, while developing a software, we create an interface with many methods in it, and our classes implement this interface. However, they might need only few of its method. Still, as per the contract with the interface, we have to override all the methods. So this will cause the overburden on our classes, or we will have the empty overridden methods inside our classes. This principle says if we apply it properly, then we have to split our interfaces into smaller subset, and we can make sure to implement only responsibilities that are required. So this principle talks about breaking down our interfaces into smaller chunks. Instead of creating a single interface with many responsibilities inside it, we should break down that interface into smaller ones. So now let's go ahead and see some code that violates this principle. So as part of the demo, I'm going to create a software which is responsible to handle the athletes. So if we see the athlete, he will have the responsibility to compete, swim, high jump and long jump, etc. So I'm going to create an interface called athlete and will put the behaviors inside it. And whenever I want to create an athlete who can swim, for example John Doe, so I will implement this athlete interface, and as per the contract I have to override all the methods from the athlete interface. However, as this is a swimming athlete, he is only responsible for compete and the swimming, but this high jump and the long jump, these are the overburdening responsibilities for this athlete. On a similar note, if I want to create a field athlete who is responsible for high jump, still I have to override all the four methods from the athlete interface, and the swim and the long jump, these are the overburdening responsibilities for this athlete class. So as per the ISP, this is not the good design. We are violating the interface segregation principle and we are overburdening our classes. So the now question arises how we can fix this. Okay, so the principle itself says we have to break down the interface into smaller chunks. So we will create three interfaces. One for athlete, we will hold the compete behavior, which is the common with for all the athlete. We will create one more interface for the swimming athlete who will be responsible for the swimming and which will be extending from the athlete. And on a similar note, we will create a jumping athlete who will extend the athlete methods, and we will extend the athlete interface and will hold the responsibilities required for the jump. And to create a swimming athlete, we will just have to implement swimming athlete and we will get the required behavior without overburdening the swimming athlete. And on a similar note, to create a field athlete, we will implement the jumping athlete interface and we will create a class for it. So as per the interface segregation principle, this is a good design. We are not overburdening our classes with the additional responsibilities. So that's how we can fix our problems with the smaller interfaces. Let's go ahead and see the few of the benefits that we get from this principle. The first benefit is we will get a maintainable and robust code, which will result into high cohesion. That means we will have the better understanding of our code and our code will be the robust. The next advantage we will get is the low coupling. That means we will be able to maintain our code in a better way. So these are the few advantages of the interface segregation principle. So that's it for this tutorial. If you guys have any questions, comment, please post those. I will answer them. Thank you guys.